Hello everyone. In today's video, we are going to study about the Karnaugh map, which is also called as the K-map in short. So what is this K-map? Where we are going to use this? That we are going to study completely in this particular video. So this K-map is nothing but the graphical method of simplifying the Boolean expression. So what is this graphical method of simplifying the Boolean expression means? Initially, in order to solve any given Boolean expression, we were looking for the common factors in between the terms. And then the terms madhya, we were looking for the common factors and we were getting some of the variables inside the bracket. So we were trying to eliminate those variables within the bracket using some of the Boolean rules. Say for example, I was having a, expression like this: a bar bc plus a bar bc bar. I was having some kind of expression like this. So in between these two variables, I was looking for a common factor. Like the common factor is a bar b, and within the brackets, I was getting c plus c bar, this value was equal to 1 according to the Boolean rule. So the answer or the simplified version of this particular expression is a bar b. So this will become a tedious method when I am having many number of terms. ಇಷ್ಟೊಂದು number of terms ಇರುವಾಗ this method will become a lengthier one or the tedious one. So what we are going to do is we are going to use this Karnaugh map or the K-map, which is very simple and effective method in order to solve this Boolean expressions. This K-map uses a systematic approach in order to solve the Boolean expression. So in this particular K-map, we'll be having boxes which is called as cells. We'll be having boxes, a number of boxes, and those boxes will be called as cell. And each cell will be having one particular combination of variables in the product form. So each cell will be having a combination of variables in the product form anta helidre, like product form anta helidre a bar dot b or abc or ab C bar D, like this in the product form. So what is this cells and how we are going to write this cells and the not? So if I am having two variables, the K-map will be having 2 to the power of n number of cells for n number of variables. So if I am having n variables, the number of cells will be 2 to the power of n. So from this, I can easily count the number of cells which is required for different variable number. If I am having two variables, then the number of cells will be 2 to the power of 2, which is equal to 4 cells. For three variables, 2 to the power of 3, which is equal to 8 cells. Are you getting? 4 variables idre 2 to the power of 4, which is equal to 16 cells. So each cell in the Karnaugh map or the K-map will be having a particular combination of variables in the product form. Each cell will be having the address anta helbodu or a product form in this particular manner anta helbodu. Now let us try to draw the number of cells for different variable number. If I am having only two variables, I will be having 4 cells anta helidre. The 4 cell structure will be like this. I'll be having 4 cells. After this 4 cells, so variable numbers can be a and b or x and y or p and q or y and z, anything. When I want to number the cells or when I want to give the variable name ಅಂತ ಹೇಳಿದ್ರೆ, this is a bar a, this is b bar b. This is the systematic approach. I have to write the variables in this particular manner itself for two variables or 4 cells. When I am having 3 variables, the number of cells will be equal to 8. So 8 can be written like this. So I'll be having 1, 2, 3, 4, 5, 6, 7, 8. 8 variables. So and 8 variables and the 8 cells. 8 cells and the header, I'll be having 3 variables. Let us use these common variables itself, ABC and then use ಮಾಡ್ಕೊಳ್ಳೋಣ. So this side I'm going to write A and this side I'm going to write B. So this is A bar A, B bar C bar, B bar C, BC, BC bar. The 8 number of cells can be arranged in this manner, Or I can also draw 8 cells for 3 variables in this manner also. Here A C and here A B, C bar C, A bar B bar, A bar B, A B, A B bar. So I can use this K-map for 3 number of variables, either horizontally or vertically. Any of the method can be used. When I'm having 4 different variables, the K-map will be, I'll be getting 16 in number of cells. 2 to the power of 4 is equal to 16 number of cells, and the structure will be like this. I'm having 4 variables. I'm going to say A, B, C, and D. So here I'm going to write A, B variables, here B, C, C, D variables, A bar, B bar, A bar, B, A, B, A, B bar. And here C bar, D bar, C bar, D, C, D, C, D bar. So this is the method we have to write for 2 variables, 3 variables, any one of this method, and 4 variables. So after writing this map, we have to come up with filling these cells, and each cell will be having its own combinations of variables. So this is the structure of a K-map. After this, the decimal equivalent of these numbers or these variables can be written as, we already know that if the value of a variable is 0, then we'll be representing that variable by placing a bar. By placing a bar upon that variable, I mean to say we are going to write it in complemented form. If the value of the variable is equal to 1, then that variable will be written in its uncomplemented form. So here B bar means its value is equal to 0 and this is equal to 1. Here 0, A bar means 0 and this is equal to 1. We can also number the cells. Cells na kuda ನಾವು number ಮಾಡಬಹುದು, which will be easier for us to simplify the Boolean expressions. How to number that? Before that, let us write these decimal equivalent. Both the values are 0, 0, 0, 0, 1, 1, 1, 1, 0. 1, 1 yake? Because both the variables are in uncomplemented form. 0, 1. If I am going to write here 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. And here 0, 0, 0, 1, 1, 1, 1, 0. And here 0, 0, 0, 1, 1, 1, 1, 0. And now we can number the cells. Cells can be given a different number, but that is also a systematic approach. We have to use the same method. So 0, 1, 2, 3. Here 0, 1, 2, 3, 4, 5, 6, 7. You have to write in this manner itself. 0, 1, 2, 3, 4, 5, 6, 7. Okay. Coming to this. 0, 1, 2, 3, 4, 5, 6, 7. Coming to the fourth variable, 4 variable K-map. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. This is how you can number the cells for 2 variables, 3 variables or the 4 variables. This is the decimal equivalent of each cell in the K-map. Now let us try to write the min terms for each of the cells. Min terms for each of the cells and in the last SOP and POS method, I told you if it is in the SOP form, canonical SOP, I have to get the canonical SOP. Canonical SOP and each term in the Boolean expression must contain all of the variables. If I am going to write the expression like this, AB bar C plus AB plus BC ಅಂತ ಹೇಳಿದ್ರೆ, this is not the canonical SOP. If I want this expression to be converted into canonical SOP, I have to first identify the terms I have to identify the variables which is missing in each of the terms. Then I have to multiply this with the missing variable and its complement. ಇಲ್ಲಿ A plus A bar. So after that, after simplifying, I have to make sure that each of the variables, each of the terms contain every variables. So this cannot be marked, or this cannot be this expression cannot be solved using the K-map. I have to convert this into its canonical form, then I can use this. So each term after converting, I suppose I don't know how I'm going to get a b c bar plus a b c plus a bar b c. After solving this, I'm going to get the expression something like this. So these terms are repeated, a bar bc, even ABC is repeated, plus ABC plus ABC bar. So this is the canonical form or the standard form, where each term is having each of the variables, and these terms will be named as m0, m1, m2 ಅಂತ ಹೇಳಿದೆ. I mean to say, not this exactly. I had asked you people to write a truth table of 3 variables and write for m0 ಅಂತ ಹೇಳಿದ್ರೆ 3 variables ಆದರೆ all the values a b c values were equal to 0. m1 ಅಂತ ಹೇಳಿದ್ರೆ 0 0 1, m2 ಅಂತ ಹೇಳಿದ್ರೆ 0 1 0, m3 0 1 1, like this. So these terms will be called as minterms, which will be represented by small letter m. So now let us try to write the minterms or the variables inside each of the cell. For this particular, a bar b bar, a bar b bar, and for this particular cell, a bar b. Clear? This is a b bar and this is a b. These are the minterms. We can directly solve looking at the expression, but that will come to that later. Okay, and the minterm for this is a bar b bar c bar, a bar b bar c, a bar b c, a bar b c bar, and for this, a b bar c bar, a b bar c, a b c, and a b c bar, which is combining a b bar c bar, a b bar c, a b c, a b c bar. I'm just overlapping these variables and filling that inside the cell. And for this, a bar c bar c bar, sorry, a bar b bar c bar, a bar b bar c, a bar b c bar, a bar b c, a b c bar, a b c, a b bar c bar, and for this, a b bar c. Similarly, for the fourth this thing, for 4 variables which contains 16 cell, a bar b bar c bar d bar, you have to fill the variables, and I want you people to fill the variables inside this cell and send me the pic of that. Okay, try to recognize the variables and write accordingly and fill accordingly the variables inside each cell. Till now, what I said was just the basics of the K-map, how to number the cells or how to fill the minterms for each cell. That we saw now. Now we are going to see how to plot the K-map for the expression which is present in the SOP form, sum of product. And one thing what you have to remember is the SOP. These are the examples for SOP. One thing what you have to remember is the expression must be in the standard form, that is the canonical form. Here I have taken the standard SOP itself. I mean to say each of the term must contain all of the variables. This is an expression for 2 variables and this is an expression for 3 variables. For 2 variables I have to write 4 cells. For 3 variables I have to write 8 cells. Here I have already written the K-maps for 2 variables as well as for 3 variables. Now what you have to do is you have to fill once of the minterms which is given to its corresponding cell. You have to identify the terms a bar b and ab is given. For that particular cells, you have to write 1 and the remaining cells has to be filled with 0. I mean to say a bar b is given. A bar b, this is the cell which is having a minterm of a bar b bar. So here I cannot write 1. So coming to this particular cell, a bar b, that is what we wanted. Identify the cells of the minterms and place ones over there. And I want AB. Sorry, here it is A. So AB, this cell is, the minterm of this particular cell is AB bar and the minterm of this is AB. So here I'm going to write 1. So whichever minterms are given, you have to fill 1 in that particular minterms and the remaining cells has to be filled with 0. Coming to the 3 variable one, A, B, C bar. Identify which cell contains A, B, C bar minterm. A, B, C bar. This is the cell which contains A, B, C bar. This one. Now the second one, A bar, B bar, C. A bar, B bar, C. Next, A, B, C. A, B, C. And the remaining cells must be filled with 0. Like this, you are going to plot the K-map for 2 variables as well as 3 variables. This is the expression, Boolean expression, which we have to solve using K-map, and the expressions will be given in this manner itself. Y is equal to, Y is nothing but the output. Y is equal to this particular expression, and for it contains 4 variables A, B, C, and D. So for 4 variables, I have to write 16 number of cells. I've already written the K-map structure over here. Now I have to fill the ones which for these variables, for these minterm variables. A bar, B bar, C bar, D. Try to identify A bar, B bar, C bar, D. This is the first cell. A bar, B bar, C, D. A bar, B bar, C, D is over here. Next, A, B, C, D. A, B, C, D. A, B, C bar, D. A, B, C bar, D. So I am having 4 different terms then. So I have filled 4 ones, and the remaining cells will be filled with 0 like this. So this is a 4 variable K-map, plotting the K-map for 4 variables which contain 16 cells. This is another method of plotting the K-map with the help of truth table. The truth table will be given. The truth table means the output will also be given. You have to look into the truth table and then you have to fill the K-map. In this particular truth table, I am having 2 variables A and B. For 2 variables, I'll be having 4 different combinations and its output is also given over here. So what you have to do is you have to plot a K-map with the help of this truth table. For that, you have to write the minterm expression. Output value is equal to 1. Here in this particular case, the input values A and B both are equal to 0. In that case, you have to write the complemented form of the variables A bar, B bar and the variable. So this is the second case where output is equal to 1 and the input combinations will be equal to 1 and 0. 1 is present, so write the variable name in the uncomplemented form. B value is equal to 0, so I am going to write B bar. So A bar, B bar and AB bar is the minterm variable expression. Coming in numbering the minterms means here what is this particular value? 0, 1, 2 and 3, and the minterm will be numbered as M0 and this M2. M2. So looking into these variable terms, you have to just fill the K-map with ones and the rest of the places or rest of the cells will be filled with 0. A bar, B bar. A bar, B bar means this is the cell. A, B bar. A, B bar means this is the cell. And the remaining cells will be just filled with 0. This is a case where the K-map will be plotted looking into the truth table. So this is an example for 2 variables truth table. Then I'm going to give you a truth table for 3 variables as well as 4 variables. I want you people to plot a K-map in this particular manner and send me the pic of that. Clear? So that's it for this video. We saw the basics of the K-map. In the next video, I'll come up with the methods of solving the given Boolean expression using this K-map. So until the next video, take care. Bye-bye.